So in this video, we shall talk about a concept called analysis of variance. And indeed, before all this theory was developed, people actually considered linear models as analysis of variance. So we shall learn about this concept in this video. Now we shall start with our familiar example where we have got only one factor input. So as an example, we can consider this, where I have got a plot and the only factor input is the variety. So we are showing different varieties of the same crop and then we are measuring the yield. So for what we are going to do, we shall forget for the time being all the linear models, etc. that we have learned and tackle the situation in a way by which early statisticians used to tackle the problem. So here we are talking about different varieties and their corresponding yields. Under each variety we have a number of plots. Suppose under each variety we have say different number of plots, say ni many plots under variety I, and say we have got 3 varieties. So we have got how many numbers? Summation ni, call it n, that many yields. So if I just plot them in a number line, I will get a plot which looks something like this. So here I can see this is my number line and the 3 varieties I have colored as red, green, blue. So I have got all the red points here, a tight cluster, all the green points, another tight cluster, and the blue points here is another cluster. So I've got 3 clusters of points. This is where I am showing the yields, the timeline, not the timeline but the number line. Now if based on just this I ask you the question, do you think that the different varieties behave differently in terms of their yields? What would you answer? Just intuitively. The answer is obviously yes. The 3 varieties are different because I can see that here is one cluster and another cluster, and these 3 clusters are well separated, which means that the red cluster the red variety on an average produces higher yield and the green variety produces the minimum yield. So the 3 varieties are really different. You will actually go for the red one. You will be ready to pay more price for the red variety than for the green variety from the viewpoint of the farmer. Now, how did I conclude this? Did I do the following? I just took the average of red, average of blue and average of green and said that average of red is more than average of blue, average of blue is more than average of green. From this I concluded that? No, not entirely that. Because if I just change the numbers in a way such that the averages remain the same like this, so here the numbers have all been changed, the points have been redistributed in a way such that the averages are still the same. May not be quite apparent because the points are so much scattered now, but still I assure you that the averages are the same. So still you have the red things which are maximum, the green things which are minimum, and blue thing in between, exactly the same averages. Will you now say that the 3 varieties really differ a lot? No. Now we will say that all the 3 varieties are more or less comparable. Why? So it is not that you merely looked at the center points of the 3 clusters. You also cared about how well separated the clusters were. So how much variation you were seeing within each cluster, and compared with that, how well separated the 3 means were. So that's what is actually a statistician or even a layman would use in order to decide whether the 3 varieties really differ among themselves or not.